Hey, welcome back to Math with Patrick and Quill. Today is November 5th, and we're solving problem 309 from the Daily Epsilon calendar. And x should be 5 today, and let's figure out why. So it looks fairly simple. We just have this kind of weird equation with x where it is equal to the same thing as 3,125 to the power of 1 over x. And I think I want to talk about fractional exponents real quick before we actually dive into this problem today. So let's talk about actually square roots too, because radicals relate to fractional exponents. Just like the definition of a square root is that when you multiply it to itself, you get the number underneath the square root sign. If we were talking about a cube root instead, again, just by the definition of a cube root, we would need 3 of those numbers to multiply to get to this one. And so if we had like an nth root, just like any number here, n, we would need n number of roots to get to that target number underneath. And so what we can do here is just kind of like get a relationship between radicals, these things, and fractional exponents. So let's say I wanted to rewrite this cube root as something where it's like x to the power of something, and I'll just put an a right here. So it's x to the a times x to the a times x to the a is equal to just x. Anything to the power of 1 is just itself, so I can put a 1 there. And then when you're multiplying things that have the same base and different exponents, you can just add those exponents together like this. The idea here is if I have, like, say, x squared and then x cubed, we overall have just 5 x's all multiplied to each other. And so we can add the 2 x's and the 3 x's, and they multiply to 5 x's altogether. Using this kind of product rule, I can add my exponents. This shows that x to the power of 3a must be equal to x to the power of 1. And matching these exponents, we can see that this a right here must be 1/3. And we can do this for any radical here. Essentially, this 3 is the same 3 right here. So in sum, if we have this number to the power of 1 over x, it's kind of like we're taking the xth root of this number. Or in other words, we're trying to find some mystery number where we multiply it some amount of times, x number of times, to get 3,125. At this point, we could do a little bit of guess and check. Like, we could just try some whole numbers and see what happens. So like we could plug in 2 and see if these things are equal to each other. And this equation is stating that 2 is equal to the square root of 3,125. And that's just not true because 2 is the square root of 4. And essentially, this number over here is like way too big for it to even have a chance of being equal to 2. And also, I'm noticing here that this number has like a lot of 5s as factors. And so I am just pretty sure that if we stick a 5 here and a 5 here, it's going to be true. And we should just double check by seeing that the 5th root of 3,125 is actually 5 itself. In other words, if I do 5 times 5 times 5 times 5 times 5, I should get this. And if I do get 3,125, then this equation right here is true. So 2 5s together makes 25. 3 of them is 125. 4 of them is 625. And then 5 5s all multiplied together does give 3,125. So yes, indeed, 5 is the 5th root of 3,125. And we're all done. So thanks for watching. Thanks for coming along. And I'll see you tomorrow. Bye.